Hi, my name is Peter Fusigna, and I worked alongside Charlie Roth on our IE441 Senior Capstone project. Our client company this semester was KTPacer, and this is our final presentation. So, KTPacer uses a telehandler to deliver parts from their outside storage yard to the assembly facility for production purposes, but they also utilize that telehandler to load and unload shipments that come in on trucks in the shipping receiving zone. And because of both of those responsibilities, what happens is production can experience delays when they request a part for assembly and for a production delivery while the telehandler is unloading a truck or loading a truck, and vice versa. The main objectives that we had for this project were to reduce the labor time to receive shipments by 35%, as well as reduce assembly part delivery delays by 50%. One of the methods we used during our current state analysis was a spaghetti diagram, or a continuous flow diagram. And what we did was we mapped out the telehandler movements through both in-person and virtual observations. What we found was in that top image, there's a very high density of telehandler movement in that top right corner, which is the shipping and receiving area. And by reducing that or eliminating that, we see the future state, which would be the bottom image. And so you can see that without that density, it frees up the telehandler to be working on other tasks, such as those production part deliveries. The next method that we used for the current state analysis was a work sampling study, where we tracked the time that it takes to unload shipments. What we found over 36 observations was that it takes about an average of 18 minutes to unload a shipment with the telehandler, and through surveys conducted, we knew that KTPacer sees anywhere from 4 to 12 shipments each day. And so we were able to find that the telehandler at a minimum is spending over an hour each day just loading and unloading shipments, and some days it can be over 3 hours.
Based on the data collected in the CSA, we came up with a couple of solutions in our FSD, the first of which is adding concrete padding around the shipping receiving building. This concrete padding would provide a level and smooth surface that would allow forklifts to operate on and unload shipments. By allowing the forklifts to unload shipments, the dependency on the telehandler to perform these tasks would be decreased and thus give it more time to complete part deliveries to assembly. The second solution we came up with was a queuing system. This would allow production operators to mark what part they needed, when they needed it, and where they needed it. By providing a visual schedule, this would allow for the telehandler operator to plan out his production deliveries around other responsibilities that he has. Continuing with the queuing system, the implementation would require 6 access point stations set up in zones A, B, G, H, I, and M, where production operators could input the parts that they needed. It would also include a tablet for the telehandler operator in which he could view that schedule. After discussion with our client, it was determined that another forklift would be added to the shipping receiving building so that the shipping receiving and repairs department would not need to share one. The benefit of adding a forklift would be that it reduces the unload and load delays, as well as reducing the reliance on the telehandler to store parts. Based on our proposed solutions, we expect to decrease production delay by 50%. This translates into a 4.5% increase in production, or 16 additional units per year, which would provide $1.5 million in additional revenues. The costs associated with the project are listed below.